Okay, so we should be live, and we're going to be talking about Kubernetes, and it's an open source platform that automates the management, deployment, and scaling of containerized applications. Remember last time we talked about images and containers? So basically, images are kind of like recipes containing like instructions, source code, configuration, and libraries that are needed to build an application. And a container is a live version of a recipe. So you could use an analogy like a recipe of a cake that you make or bake, and the actual cake is the container. So you can make many cakes out of one single recipe. And what it does is basically Kubernetes creates and manages containers on cloud-based server systems. It can assemble computers into a cluster, run workloads in containers, automatically deploy, scale, maintain, schedule, and operate containers, automatically place containers based on resource requirements, mix critical and best effort workloads, scale applications up and down with a simple command with a UI or automatically based on CPU usage. How it's used. Kubernetes is used by application developers, IT system administrators, and DevOps engineers. It's used across companies including Google, Microsoft, Amazon, Apple, Meta, NVIDIA, and as Reddit and Pinterest. Kubernetes is also known as K8s or Kube. The name Kubernetes comes from the Greek word Kubernetes, which means helmsman or a pilot. The helm in the Kubernetes logo is reference to this meaning. The helm. So what is the helm? So if you look at it, basically something like this. Okay? How it works, Kubernetes works with various container runtimes, such as containered, and CRIO. Containers run on top of the common shared operating system on all host machines, but are isolated from each other unless a user chooses to connect them. So that's basically what a Kubernetes is. It's basically an open source platform that that automates the management and deployment and scaling of containerized applications. Um, so automatically place containers based on resource requirements, mix critical and best effort workloads. We're going to talk about all of this and we're going to learn about all of this. So let's dive into some of the past example. First of all, we're going to be creating a multi-container application with Docker Compose. Lets you define and run multiple services like a web server and a database together in a single configuration file. Docker Compose simplifies orchestrating multiple Docker containers so they can work seamlessly as part of one application. Let's go step by step through this and use setup and use of Docker Compose for basic multi-container app. What is Docker Compose? Well, Docker Compose is a tool that allows you to define and manage multiple cloud Docker containers in a single YAML file. So we have a docker compose.yaml. Instead of manually starting each container, you can start all of them with a single command, and Docker Compose will handle the networking and environment setup. We'll think of a scenario which is, imagine you want to set up a web application that needs a web server like Nginx, okay? And a database like MySQL. With Docker Compose, you can specify both of these services in a single docker compose.yaml file and have them interact with each other. So how do you do this with a single docker compose.yaml file? Step-by-step guide to setting up a multi-container app. Okay, so we have created docker compose.yaml file. In your project directory, create a new file called docker compose.yaml. This will define the different services containers that make up your application. Here's an example docker compose.yaml file. So what we're going to do is we're going to go in our project directory. We're going to contain a multi-container app. So what I'm going to do is I'm going to go here. So you can see over here I have Docker project, right? So for this, I would create a new folder, and this folder will contain the name as multi-container app. Okay, so I'm gonna write F2. Sorry, I'm gonna write over here F2, and then we'll have multi-container, and then we have app. Okay, and then we go inside here, and then we do cmd, and then we have code dot. Now, what we need is a Docker Compose file, right? So for that particular reason, what I'm going to do is I'm going to make sure we have this over here, and we could pull up this one on the left. Okay, so if I just cross this out, so you can see over here, um, basically we're using Docker Compose to set up all this, right? Creating a multi-container application with Docker Compose lets you define and run multiple services like a web server and a database together in a single configuration file. So Docker Compose is a tool that allows you to define and manage multiple Docker containers in a single YAML file. Instead of manually starting each container, you can start all of them with a single command, and Docker Compose will handle the networking and environment setup. So to create that, first we create a dockercompose.yaml file. If you go here, I type in docker-compose, and then we have .yaml, like this, YML. Okay, and you can see now it's created some file over here. So here's an example docker-compose.yaml file. We have version 3 services, and then we have a web. So remember, like a scenario that we chose, we say that we need a web server like Nginx and a database like MySQL. With Docker Compose, you'd specify both of these services in a single thing. So we say services in the web, and then image is basically Nginx, and the ports, we have maps port 8080 on your host, which is our computer, to port 80 on the container, and networks is app network. After that, we have the DB, which is the database, is the image of MySQL environment, which is MySQL root password equal password, sets the MySQL root password to password, as well as networks, which is app network. And then after that, we have networks, app network, and driver bridge. So explanation gives us some of the explanation here, whereas version specifies the Docker Compose file version. Version 3 is a widely used and compatible with most setups. We have services, and then we have web defines the web service, which uses an Nginx image and maps port 80 on the container to port 8080 on your machine. DB defines the database service using a MySQL same image. The MySQL root password environment variable sets the root password for MySQL. All right. After that, we have networks, and then this is basically networks, and then we have app network. Creates a custom network called app network using the bridge driver. This network allows the web and DB services to communicate with each other within the same network. So it allows us to communicate with each within the same network. So run Docker Compose. So once your Docker Compose.yaml file is set up, you can start the services with a single command. In the terminal, you could run that in. So I'm just going to copy this, and I'm going to paste it right here. Okay, so we have our Docker Compose.yaml file. We'll go into this file, reveal in File Explorer. So reveal in File Explorer, and we could add in this as CMD, making sure that we have the CMD here. Now all we gotta do is we have to run the following. We gotta run this command, which is to run the Docker Compose, run Docker Compose. So in the terminal, run Docker Compose up. So Docker Compose up starts all services defined in the Docker Compose.yaml file. If the images aren't already downloaded, Docker Compose will pull them directly from Docker Hub, remember? So -d optional runs the containers in detach mode in the background, remember, like last time. Verify the containers are running. You can check the containers using Docker Compose PS. Okay, so the running containers. Now this command will show the services and their status. You should use web and DB services listed and running. This command, basically Docker Compose PS, the command will show the services and their status. You should see web and DB services listed and running. So let's start out with Docker Compose up, right? So if I type in Docker Compose and then say up, this would run the thing that we need. So yep, so you can see over here we have Attribute version is obsolete. It will be ignored. Please remove it to avoid potential confusion. Error during connect. So we have some issue over here. Okay? Can't find file specified. So let's just copy this error prompt and make sure we are within that same area. So if I look at Docker hyphen version, if I do that, Docker will return this. But if I say Docker hyphen compose hyphen version, I'm not sure about this. Docker compose version we also have. Okay, so essentially we want Docker hyphen compose, and we have PS. Remember process state. So over here we get this kind of issue. So the best way to go about this is just return this message here. So it says this error can happen for a few reasons, often related to the Docker desktop setup on Windows. Let's go through some steps to troubleshoot and resolve this issue. Check Docker desktop configuration. The error message suggests that Docker Compose is attempting to connect to the Docker desktop Linux engine, but it may not be enabled or configured correctly. Open Docker desktop and go to settings. Under the general tab, ensure use the WSL2 based engine is enabled for most cases on Windows 11. Restart Docker desktop with any changes. Verify Docker daemon is running. Docker desktop on Windows requires the Docker daemon to be running. Make sure Docker desktop is fully running before executing Docker Compose up. So essentially what we need is Docker Compose up and running. So let's fire this up using Docker desktop, and it should open it up. So once Docker desktop on Windows requires the Docker daemon to be running, make sure Docker desktop is fully running before executing Docker Compose up. Look for the Docker desktop icon in the system tray, bottom right corner of the screen. If the icon is there but shows it's not running, click start, right click and click Start Docker Desktop. Wait until it fully loads and shows Docker Engine running. So it's basically the system tray over here. It should have it appearing with a couple of times. Um, and it should say then Docker Engine running. Test Docker command independently to check if Docker is working correctly. What you could do is run a simple Docker command to ensure Docker can communicate with your local environment. Okay? And then after that, we have open a terminal and run Docker run hello world. And this command runs successfully, Docker is running correctly. So if I run this command, which is essentially I was trying to run Docker, but for some reason it's taking a little bit of time. If I bring it back here, let me see if I, so if I go, yeah, so let me just go back here. So yeah, so let's open this up, making sure that this works. Hoping that it turns on. In the meantime, we could just run Docker run hello world. So let me just CLS this. Docker run hello world. So I would say Docker run, and then we have hello hyphen world. So let's see what happens here. Unfortunately, my environment is not running with Docker. Slow computer, but see what it does. It's finally turned on after a long time, but let's see what it does actually. Also, this is kind of stuck or something too. So this is the Docker desktop UI. So we see it's a personal. And what we can see over here is hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. The Docker client connected the Docker daemon. The Docker client basically contacted the Docker daemon. After that, the Docker daemon pulled the hello world image from the Docker hub, AMD64. The Docker daemon created a new container from that image, which runs the executable that produces the output you are currently reading, which is basically this one. After that, the Docker daemon streamed that output to the Docker client, which sent it to your terminal. So what happened? The Docker daemon streamed that output to the Docker client, which sent it to your terminal. And try running more ambitious. To try something more ambitious, you can run an Ubuntu container with Docker run -it Ubuntu bash. Share images, automate workflows, and more with a free Docker ID. So we have hub.docker.com. For more examples and ideas, visit this stuff. So yeah, I mean, this is pretty cool. What we can do is now we could try to run that same command because now we have Docker. You can see that the images, for some reason, are right here, and they can be reused over and over because we created these 22 hours ago, like in the last stream. You can see my node app, as well as the welcome to Docker image, as well as the hello world image. But if you look at the containers, nothing should be running. So you could see exited, exited, exited. That means nothing is running, and they're all in like closed states. But if I turn this application thing on, so if I go back up here and run the Docker compose up command, so starts all services defined in the Docker compose file. If the images aren't already downloaded, Docker compose will pull them automatically. So let's say Docker -compose, and then we have up. If I do this, what happens is that you're seeing that um, things are happening here. So what we're having is Docker compose YAML. The attribute version is obsolete. It will be ignored. Please remove it to avoid potential confusion. So we're basically pulling um, the download we needed for the Nginx server, web server, right? As well as the MySQL database. So both of these things are being pulled through our Docker system from the Docker hub, and it's taking some MBs. So you can see 148.9, and it's going to 150, and it's going to 160, 170, and pulling out of the total, which is 173.9. We're almost done. Once it's done extracting, we'll see our completion taken care of. So you could see that this is being extracted and pulled successfully. After that, we have running 01. We have a network multi-container app network which is created. We have a container multi-container app db1, and then you can see over here we have kind of like a lot of information created, and a lot of this is there. So that's pretty cool. We see all of this commands, and you can see over here that we created a multi-container app. View in Docker desktop, O for view config, and W for enable watch. Okay, so this is the terminal, and it does the thing, verify the containers are running. So you can check the containers running with the command. So if I if here with just type in v, honestly the I know DB initialization was ended. So if I go to this Docker desktop, you'd see something running, which is a multi-container app. Okay, and within this multi-container app, you would have Nginx running as well as MySQL, which is insane. Um, so basically, that's the containers, and this is container memory usage is 157.75 MB out of the 5.61 GB. So that is just incredible. And these are some of the containers that are lively running. Images, you could see on the other hand, Nginx and the MySQL image. We have some formulas here, recipes here, and they're being used by this active multi-container application. All right, so that's essentially it. If I just turn this off, so this is just going to show you some more information, and if I turn this off using Control C, it basically should turn it off. So let's see what happens here. So you can see over here the containers are exited using that force stop that I've done. So basically that was the command. Um, access the web server with the setup above. You can access the Nginx web server by opening your web browser and going to this port. The URL will show the default Nginx web welcome page if everything is configured correctly, breaking down sections in Docker compose.yaml. And so, for instance, we close it. We could also run again using the same Docker compose up command. So again, just type in this, which is Docker compose up, and it should run the DB and the web, um, and you should essentially be able to view it using this HTTP :/localhost port 8080. Okay, so if I just write here and paste it, you should see the Nginx server up and running. Welcome to Nginx. If you see this page, the Nginx web server is successfully installed and working. Further configuration is required. For online documentation and support, please refer to nginx.org. Commercial support is available at nginx.com. Thank you for using Nginx. Basically, this is the org website, and this is the commercial website. All right, optimize, deliver, and secure apps across the entire enterprise with Nginx. So yeah, that's basically it. Go back. We'll see that our multi-container app is running again. If you go to the terminal, we'll see that the same process has been appearing here. And yeah, you could enable this, or you could just say V, which is view in terminal. You can see everything in the terminal. And if I press this, it just opens up the Docker desktop application. Fascinating stuff here. So if I go here, the URL will show the default Nginx welcome page if everything is configured correctly, breaking down key sections in Docker compose.yaml. Ports in the web service, the ports field maps port 8080 on your host to port 80 on the container. This allows you to access the Nginx server from localhost 8080. Environment variables, the DB service uses environment variables to configure MySQL such as setting MySQL root password. These variables will be passed to the container when it starts. And then we have networks. The networks section contains so over here we have key sections. If we look at ports in the web service, the ports field maps the ports field maps port 8080 on your host to port 80 on the container. This allows you to access the Nginx server from localhost port 8080. Environment variables, the DB service uses environment variables to configure MySQL, such as setting MySQL root password. These variables will be passed to the container when it starts. Networks. The network section defines a custom network so that web and DB communicate. So DB services can communicate. Using a custom network with Docker Compose allows services to reference each other by name. So in this case, the web can reach the DB server simply by using DB as the host name. And then we have usable Docker Compose commands. Here are some commands that you'll find helpful as you work with Docker Compose. One is Docker Compose up-d, which starts the services in detach mode running in the background, right? Which is composed of, it starts the services in detach mode. Then Docker Compose down stops and removes the containers, network, and other resources defined in Docker Compose.yaml. We have Docker Compose PS lists all containers created by Docker Compose and their statuses. After that, we have Docker Compose log shows logs of all running services, which is useful for debugging. Example project directory structure. So we have for a typical multi-container app with Docker Compose.yaml, only one directory structure will look. Only your directory structure should look like this. Will basically look like this by my multi-container app, and inside we have a Docker Compose.yaml file. Compose file defining web and DB services. If you add more resources such as custom configuration files for Nginx or database initialization scripts, you would add them in this structure. Expanding on this example, basically you could expand it and also summarize as basically Docker Compose allows you to easily define and manage multi-container applications, streamlining your workflow and making it easy to spin up complex environments. This Docker Compose.yaml file serves as the configuration blueprint for your app services, defining how containers should interact and be exposed to your host machine. Would you like more help? Basically, that's the gist of it. Docker Compose allows you to directly, essentially, what it says is that it allows you to easily define and manage multi container applications. Allows you to easily define and manage multi container applications, streamlining your workflow and making it easy to spin up complex environments, right? This Docker Compose.yaml file serves as a configuration blueprint for your app services, defining how containers should interact and be exposed to your host machine. All right, so that's basically it. Now let's look at Kubernetes. So the last thing that we should do is Docker PS. I told that's process state. If you look at PS, it basically means process status. So it originates from the Unix Linux command PS, which displays information about active processes on the system. In the context of Docker, the Docker PS, which is the process status, shows the processes or containers that are actively running. This command is similar in concept to PS in Linux or Unix, but specifically tailored to manage and monitor Docker containers. So now we can go to the Kubernetes part, and we'll see how it works. All right. Now let's look at yeah. So this is a web image and DB MySQL, and we have MySQL root password. And you understand Kubernetes. Kubernetes K8 is an open source platform used to automate deploying, scaling, and operating containerized applications. Key concepts is clusters, nodes, pods, replica set, services, and deployments. So what are all these and how they work? We're gonna be having this part. Before that, let's see. Okay, we got some questions from Saddam Suman. I have a query regarding idle timeout of Kubernetes pods. This is a problem statement. Running cloud workspace is not free. A running workspace consumes CPU and memory, etc., and contributes to the overall cost of customers' cloud resource consumption. We would like to have a timeout strategy for workspace. When the workspace is not in use to reduce the cost, what strategy should I use for it? Here, the workspace refers to a Kubernetes deployment containing ingress, service, and pod. This has to be a cloud agnostic solution. Should even not work on on-prem and environments. All right, so I have a query regarding idle timeout of Kubernetes pods. This is the problem statement. Running a weak cloud workspace is not. Uh, okay, for your answer, what we would do is we would explore Kubernetes, and at the end of this stream, I'm gonna tell you the solution for this query. But yeah, stay tuned for your response on this. So if you go back here, let's talk about understanding what Kubernetes is and how they work. So if you go here, Kubernetes K8 is an open source platform used to automate deploying, scaling, and operating containerized applications. So we have a cluster, which is basically a set of nodes with where Kubernetes runs your containerized application. And then there's other things, but one thing I would do is I'll just pause this out, and you know, I'll give you an update. Just give me a moment, please. Yeah, I'm back. So let me display my screen. You could see everything is pitch black, but you could see that I'm still audible, right? Um, so yeah, we're gonna be talking about Kubernetes. I'm gonna try to actually make something like a practical example, practical scenario. So let me show you my display, right? So let's go over here and talk about what Kubernetes is actually. So Kubernetes K8 is an open source platform used to automate deploying, scaling, and operating containerized applications. Now we have key concepts. No, it's an open source platform used to automate deploying, scaling, and operating containerized applications, right? So key concepts include cluster, nodes, pods, replica set, services, deployments. So what is cluster? A set of nodes where Kubernetes runs your containerized applications. Now, nodes are basically machines, virtual or physical, where containers are executed. Now, pods, the smallest deployable unit in Kubernetes, which can hold one or more containers. Replica set ensures a specified number of pod replicas are running at any time. Services basically provide a network access to a set of pods. And deployments is basically manage the creation and update of applications. Setting up Kubernetes on Windows 11. Enable Kubernetes in desktop. Docker desktop. In Docker desktop, go to settings, Kubernetes, enable Kubernetes. So go to the Docker desktop, settings, Kubernetes, enable Kubernetes. Start a Kubernetes single node cluster when starting Docker desktop. So we could say apply show system containers, show Kubernetes internal containers. When using Docker commands, start a Kubernetes single node cluster when starting Docker desktop. So apply and restart. So basically installation takes a few minutes and requires an internet connection. So we're going to install Kubernetes, enabling it. We're pulling images and we're going to make sure that it works, right? Again, what it says is this. It's a cluster is basically a set of nodes where Kubernetes runs your containerized applications. Okay? A cluster contains multiple nodes inside. So basically, a node is a machine or a physical or virtual where containers are executed. Some containers are basically applications that are on running state. So nodes have these, right? Nodes have these containers, but everything is inside of a cluster. Cluster have nodes, right? You could think of it like that. And then we have pods, the smallest deployable units in Kubernetes, which can hold one or more containers. So pods are deployable units in Kubernetes, and they can hold one or more containers. All right, we have like a pod, and inside of it we could have one container, one live version of an image, or more than one. So like 3, 4 containers can be within a pod. Then we have replica set, which ensures a specified number of pod replicas are running at any time. Okay. After that, pod replicas are basically things that are, pod have running containers, one or more. So replica set meaning ensuring that a specified number of pod replicas are running at any time. And we have services provide network access to a set of pods. Okay. And then we have deployments manage the creation and updation, or basically update of applications. And then we set up this Kubernetes and just making sure that this is added. It's going to take us some time, and hopefully it's going to be updated along with it. Um, that's what I'm hoping. Let's just hope it does. Complete its setup process. Then preparing configuration finally. Any other questions so far? No questions. Are these live streams ever? Are these helpful? I have a query regarding idle timeout of Kubernetes pods. This is the problem statement. I hope my screen is visible in it. I think it should be. Idle timeout. So pod, basically, you're saying Kubernetes pod. Pod is basically the smallest deployable unit in a Kubernetes thing, and a pod contains one or more running containers, right? Um, Running a cloud workspace is basically not free. That's true. A running workspace consumes CPU and memory and contributes to the overall cost of customers' cloud resource consumption. We would like to have a timeout strategy for workspace when the workspace is not in use to reduce the cost. What strategy should I use for it? Here, the workspace refers to a Kubernetes deployment, okay, containing ingress, service, and pod. And after that, it's saying um, this has to be a cloud agnostic solution. Should even work on prem ENVS. So what is basically what you're saying is that we would like to have a timeout strategy for workspace, right? Basically, you're asking for this question right here. Yeah, you're asking for a timeout strategy on how we could use this. So yeah, if we go back here, right? Yeah, that's what you're asking. Well, if we're looking for a cloud agnostic thing, um, let me see, let me see, let me see, let me see. So essentially, you're looking for something like that. Now, is this specifically for one or like the entire thing? Okay, okay, got it. Hmm. Um, but basically Kubernetes pods, um, uh, so what can it be? What I would say is if you go to, suppose we go here and I think our enable Kubernetes, I think it has been done. So I think so we have Kubernetes added with our Docker. And we could go back here to the desktop settings, right here, account settings, and let's just go back to general. I think we could cancel because everything seems to be working, and go back to containers. And these are some of the containers. You can see two of them are running. But yeah, your question, if I just search it here, it says over here that in Kubernetes, the streaming connection idle timeout is the maximum amount of time an idle session is allowed to remain before it is disconnected, right? The default value for this timeout is 4 hours, but it can be set to a minimum of 5 minutes. Setting the timeout to 0 will never disconnect any idle sessions. Here are some reasons why it's important to set an idle timeout. Prevent unauthorized access and ensure streaming connections are timed out. So basically it's saying in Kubernetes the streaming connection idle timeout is the maximum amount of time an idle session is allowed to remain before it's been disconnected. So it's just giving a time for now, and I think this one. What is the default timeout for Kubernetes pods? Setting and time the timeout limit of above 60 seconds can exhaust the API server resources, making it prone to denial of service attacks. It is recommended to only change the default limit of 60 seconds when necessary. So I think this is a nice GitHub question. One second, if I go back, this one, a way to control idle time connection timeouts. Um, I would recommend reading through this, you know, page, and this would help you out, right? The issue is I want Kubernetes to do it automatically. I need it to call needed to call an API because there are many more things that I need to update the DB for before uh, before even scaling down the deployment. Oh, oh, you can see bottom bar. You can see the Kubernetes running. There you go. Yeah, I mean, look it through this link. Tell me what you think, and then we'll basically update from there. All right. So let's go from there. So yeah, I was back here, um, and I think I was over here, and you can see over here Kubernetes is running. Thank you for that. Um, so let's go and add something over here. Once Kubernetes is enabled, you can use kubectl to interact with the cluster. All right, and we know what a cluster is. It's a set of nodes where Kubernetes runs your containerized applications. Now, basic Kubernetes commands is like kubectl get nodes, check the nodes in your Kubernetes cluster, kubectl create deployment, and then we have name, and then we have hyphen hyphen image equal to image, deploy a containerized application. Okay. After that, we have kubectl get pods, list running pods. And pods are basically the smallest deployable units in Kubernetes, which can hold one or more containers. When we write create deployment, create a containerized application, that means. All right. After that, we have kubectl expose deployment name, and then we have a port 8080 expose a deployment externally. Kubectl scale deployment, and then we have replicas 3, scale the deployment to 3 replicas. And basically, we know it ensures a specified number of pod replicas are running at any time. Replica set. After that, we have kubectl delete pod name deletes a specific pod. Practice exercises. Deploy a web server. So we have create a basic Nginx deployment. Expose it as a service. Okay. After that, access it via localhost. Port 8080. Scaling applications. Scale the Nginx server to multiple replicas. After that, observe how Kubernetes creates additional pods by running kubectl get pods. Deploy a multi-container application. Use a single YAML file app deployment.yaml to define a web app plus Redis deployment. So we have name web app, and then we have app, web app, and web app. Apply the deployment using this command. Rolling updates, update an app image while maintaining zero downtime. Combining Docker and essentially you could do both of this, but yeah, we need a little bit of help of this instructions. So what I'm going to say is I'm going to copy here. And you can see over combining Docker and Kubernetes. Docker is used to package your application into containers, while Kubernetes is used to manage and orchestrate these containers at scale. Together, they provide a powerful combination for modern cloud-native applications. Practice develop locally with Docker. Build and test applications locally using Docker. Practice multi-container setups using Docker Compose. Deploy to Kubernetes. Once you're comfortable with Docker, use Kubernetes to orchestrate the deployment of these containers in a scalable and reliable manner. More resources to learn is Docker documentation, Kubernetes documentation, um, Kata which is an online platform to try Kubernetes scenarios without setting up anything locally. By setting up Docker and Kubernetes on your Windows 11 machine and following these exercises, you'll gain hands-on exercise with both technologies. So that's pretty cool. I'll say, please explain uh, the following um, in a very easy manner. Say, I don't understand it, right? I don't understand it at all. So let's see. So let's break down each exercise into easy steps to help you understand how to work with Kubernetes for deploying and managing applications. Deploy a web server with Nginx. Go use Kubernetes to deploy or start or deploy a simple web server using the Nginx image. So what I have to do is create a deployment. This tells Kubernetes to run a certain image, like in a pod. So create a deployment in a pod. So what we have to do, run this command in your terminal. So we have this command, and I would recommend create a deploy web server using Nginx. So I'll do over here. I'll create a new folder. I'll say K8 web server using Nginx. Ginx. So what we're going to be doing here is run the following in your terminal. So we have cube ctl create deployment my nginx hyphen image hyphen equal to nginx. So basically what this command does is kubectl create deployment my nginx image. So what happened is deployment.apps my nginx created. So if you go into the folder, let's see, that doesn't do anything here, but it does something, right? So explanation is the command uses Kubernetes to create a deployment named my nginx and uses the nginx image as a container inside the pod. So basically it's a container. If you see over here, this is something what we're talking about. So yeah, so this is a multi-container app, and then we have this one which has this ID, and then this one has this ID. This is the Nginx one, okay, and it's running within a pod. So this container. If you go look at the images, we have you go to actually filter or columns. So if you go dangling in use, so we'll just filter that. And you can see over here my node app, MySQL, Nginx. Okay, registry, K8, pause. So basically K8s and the other one has been done. So you can see over here, a lot has been used, and that's why you could see the images over there. But yeah, containers over here, you could see we have the K8 Nginx and the K8 pod. All right, they're both running. So after that, after the command which we used, which was kubectl create deployment my nginx image nginx, which is this command asks the Kubernetes to create a deployment named my nginx and uses the nginx image as the container inside the pod and expose the deployment as a service. This makes the nginx web server accessible from outside the Kubernetes outside from the Kubernetes cluster. If you do expose the server, right, expose the deployment as a service. So basically we say cube ctl expose deployment my nginx we have hyphen type is equal to load balancer hyphen port is equal to 8000. So what this command did was basically kubectl expose deployment and my nginx hyphen type load balancer equal to hyphen port 8080. This command creates a service that listens. So what we did was expose the deployment as a service. Make this this makes the nginx web server accessible from outside the Kubernetes cluster. So what I did when I exposed deployment of my nginx and type load balancer at port 8080. This command creates a service that listens on port 8080. The hyphen type is equal to load balancer option lets traffic reach your Nginx server from your computer. Now access the web server. Open your web browser and go to this port. Okay. You should see the default Nginx welcome page showing your server is running. So basically this is what's it. This is how we manage it with Kubernetes. And there you go. All right. Exposing the deployment as a service creates a service that listens on port 8080. The hyphen type equal to load balancer option lets traffic reach your Nginx server from your computer. And then we have scaling applications. Goal, increase the number of Nginx pods to handle more traffic or ensure availability. Now, that's why what we're saying it's the smallest unit of deployable thing on Kubernetes is a pod. Pods contain running clusters, right? So running clusters, and it's saying that increase the number of pods, one or more clusters. And increase the number of Nginx pods to handle more traffic to ensure availability. To do this, we have to scale the deployment. This tells that Kubernetes to run multiple copies, replicas of the Nginx container. That's what we're trying to do, right? Scale the deployment. Run this command. So we're basically running kubectl scale deployment. If I do this, kubectl scale deployment my Nginx, and then we have replica is equal to 3. So we have a deployment.apps my Nginx, and then it says scaled. Okay. Explanation: you're using Kubernetes to create 3 replicas of the my Nginx deployment. Okay. Meaning there will be 3 Nginx pods running instead of 1. Alrighty. So we have Kubernetes scale deployment my Nginx replicas 3 pods. Observe the pods. To see how the running pods run, Kubernetes get pods. So you could say Kubernetes kubectl get pods, and you go see all these pods. There are basically 3 different pods that have their own Kubernetes. Basically, the 3 different pods that have their own separate Nginx server containers. So we have my Nginx pod, which is ready, running, restarts, and it has its age 6 minutes 31 seconds. We have another my Nginx, and then we have a third my Nginx. All right. So all of this is there. There's all the pods running in your cluster. This basically a kubectl get pods. This command gets all the pods running in your cluster. So basically in the cluster you have so many pods. You should see 3 pods named my Nginx XX, right? That does work with different endings listed. Deploy a multi-container application. Goal, run a small application with 2 different containers. Nginx and Redis in each pod. Steps. Create a YAML configuration file. In Kubernetes, you can describe applications using YAML files. Let's create app deployment.yaml to define both containers in a single deployment. Create a file named app deployment.yaml and paste the following. So we're going to paste the following thing into this. So if you go here, and if you just cross this out, okay. And if I go to this part here, and if I do CMD here, So we have a create a YAML configuration file. In Kubernetes, you can describe applications using YAML files. Let's create app deployment.yaml to define both containers in a deployment. All right. So how do we go about this? Again, we have to do code and dot. Okay. If I do this, it will open up my instance in the VS Code. And I would basically put it right in the left. Do you have Docker installed on your system? Do you want to install the recommended dev containers extension from Microsoft for it? And then you could install the. Then again, you'd have to close it afterwards, right? So it's container. Open any folder or repository inside a Docker container. All right. So let's do this quickly. Okay, so we have a YAML, create a YAML configuration file. In Kubernetes, you can describe applications using YAML files. Let's create app deployment.yaml to define both containers in a single deployment. Create a file named app deployment.yaml and paste the following. So we'll just have a file, name it as app-deployment.yaml like this. And you can see over here that we have this code. API version app v1, apps v1. Kind is deployment. Metadata is name equal web app. Spec replicas, we have 2 number of pods to create. Selector, match labels, app web app. Template, metadata labels, app web app. Spec containers, name web container. Image nginx, name Redis container. Image Redis. All right. So we have basically 2 containers. First container is nginx. Second container is Redis. Apply the deployment. Run the following command to start the deployment. To run the deployment, you would have a simple command, which is cube ctl apply -f app deployment.yaml. If I run this, this command tells Kubernetes to create a deployment called web app with 2 replicas. Okay. Two replicas. Each pod, yeah, so basically 2 replicas right here. A container called web app with 2 replicas. Number of pods to create. Oh, basically that's it. Each pod will contain 2 containers. All right. And 1 for Nginx and 1 for Redis. All right. Oh, okay. So that means we're going to contain 2 replicas, and each pod, which is a single deployable unit, which contains 1 or more containers, which contains 2 containers, 1 for Nginx and 1 for Redis. So basically, it's containing containers, and we do that basically using YAML. You see over here that we have that you can see deployment.apps web app created, right? That deployment is created. Rolling updates. Goal: update the Nginx image in the my Nginx deployment to a new version without downtime. So it's saying rolling updates. Goal: update the Nginx image in the my Nginx deployment to a new version without downtime. To update the deployment. So we have kubectl set image deployment my Nginx, and then we just put that version. Explanation: this command set tells Kubernetes to update the my Nginx container in the my Nginx deployment to version 1.19.0. Kubernetes will gradually replace the old pods with new ones, ensuring there's no downtime. This approach allows you to deploy, manage, and update applications seamlessly. Let me know if you want to dive into any of these concepts further, or if there's a step still that still feels unclear. So we have to just make sure that we have this updating the deployments. So we'll say cube ctl set image deployment, and we have my nginx ginx, and then we have nginx my nginx, and we have nginx is equal to nginx for 19.0. So we have the deployment.apps my nginx image updated, and that's pretty much it. That's pretty much it with this video. I hope you understood a lot about it. Any questions so far about it, feel free to ask me. Um, yeah, and that's pretty much it with this one. As you can see, get parts. So it's a cube ctl get parts. If I do that, okay, cube ctl. So we're basically creating more pods. Here we have this one running, this one's terminating, this one's running. Okay. And yeah, pretty much that's it with this live stream. Okay, so we got Satyam and sure, let me check. Is just forwarding Kubernetes so you set up more. Is just cube forward is just forwarding Kubernetes to you setup. More like port forwarding. I need a tool that can monitor the pod and give me a webhook when timeout occurs. Webhook is needed because I can then trigger an API to listen to this hook and trigger an operation when it gets triggered by the webhook. Satyam, so the thing is the live stream is over, but I would appreciate if you could find the answer and maybe just paste that in the chat or in the comment section in this of this video. And hopefully if I find any kind of solution, I'll reply back. Thanks for watching this live stream, everyone. We're concluding, and hope we see you soon. Thanks. Bye.